Welcome to the deep dive. We have a really fantastic mission for you today. We are rethinking the very concept of, well, pruning trees.
Yeah, it is a huge topic.
Right, because we are looking at this stack of fascinating notes and observations and diagrams from tree experts Kesser and Steen. And usually, pruning is all about maximizing fruit yield or just saving money.
Exactly, the traditional way.
But today, we are exploring a totally radical new paradigm, like how to deliberately prune a tree to turn it into a thriving habitat tree for insects and wildlife, while still, of course, keeping the tree's health and age in mind.
It really is a complete shift in perspective because if you look at standard textbook arboriculture, it often reads like a manual for a factory line.
Oh, cool.
You put in the labor, you prune the branches, you get the apples, and you sweep up the mess. But Kesser and Steen are asking us to step outside that transactional, incredibly human-centric mindset.
Okay, let's unpack this. Because we are so conditioned to view trees as these biological machines, you plant it, it produces. And if it isn't producing efficiently, we just assume it is broken or sick.
Right.
But Kesser and Steen intentionally avoid giving those generic one-size-fits-all pruning instructions in their notes.
They do, yeah. And the reason is that context dictates everything. The rules of how you cut a branch completely change depending on the variety, the location, and primarily your end goal.
Right, what you actually want from the tree.
Exactly. If your only goal is a massive apple harvest, you prune one way. But if you adopt what the sources call the OMA philosophy, you take a completely different path.
I found the notes on Oma so charming, but also deeply subversive.
Yeah, it really is.
Because she maintains her orchard primarily for the insects. She is essentially running a bed and breakfast for bugs.
Subversive is a great word for it, actually. It flips thousands of years of agricultural programming totally on its head. OMA's primary crop is actually biodiversity.
Right, the apples are just a secondary bonus.
Exactly. She still uses them for pie, juice, cider, vinegar, all of that. But her success metric is the life buzzing around the tree, not the literal tonnage of fruit.
Wow.
And when you prioritize insects, it completely alters the surrounding ecosystem. The soil chemistry changes because of the organic matter the insects break down. The local bird populations thrive because their food source is suddenly abundant. It creates this whole cascading ecological effect.
And before we get into the mechanics of how to actually prune for that kind of biodiversity, the sources highlight a crucial prerequisite. We have to understand how these orchard trees are actually born.
Yes, this is so important.
Because if you read self-taught internet gurus, they talk endlessly about where to make a cut, but they almost never talk about propagation.
Which is just a glaring omission. To understand the tree's relationship with humans, you really have to look at its origin. The vast majority of orchard trees are not grown from a seed.
Right, because an apple seed is a genetic lottery. It is the unpredictable result of bee pollination. Planting a seed is kind of like a tree having a kid. You have no idea what you're actually going to get. It might be delicious crisp apple, or it might be something that tastes like a raw potato.
Botanically speaking, apples are extreme heterozygotes. Their offspring vary wildly from the parents. So to get a predictable crop, humans rely on grafting.
Right.
You find a mother tree that produces the exact apple you want. Then you take a cutting, which is usually a water sprout.
A water sprout being those incredibly straight, vigorous shoots that shoot straight up from a branch, right?
Yeah, that is them, yeah. They're full of vigorous vegetative energy. So you take that water sprout and you physically attach it or inoculate it onto a completely different set of roots.
The rootstock.
Right, the rootstock. You carefully match up the cambium layers, which is that really thin layer of living, dividing tissue just under the bark, so their vascular systems fuse together.
So we are literally performing botanical cloning.
Basically, yeah.
We are controlling their birth with microscopic precision, much like a viticulturist manages vine cuttings.
We are. And Kesser and Steen point this out to establish a baseline. Orchard trees are highly curated human artifacts. We manage their origins meticulously to serve our needs.
Right.
So the question becomes, if we are going to exert that much control over their birth, shouldn't we be just as thoughtful and deliberate about how we manage their lives, their aging process, and eventually their decay?
Man, that brings us to a massive point of friction, especially in cities. What happens when our carefully curated nature clashes with human convenience?
That is the big question.
Because in the urban environment, a tree is basically just pleasant background scenery until it is suddenly in the way of a new apartment building or a widened road.
And this is where the financial realities of urban planning just collide with ecology. Developers often view trees purely as liabilities.
Right.
In the game between the ecological value of a tree and the financial capital of a building project, well, the financial capital usually wins. The standard operating procedure is simply to cut the tree down at ground level.
But sometimes there is a compromise, right? The sources talk about a skilled arborist performing a crown reduction.
Right, a crown reduction is an attempt to keep the tree alive while mitigating its footprint. The arborist will carefully cut back the outer branches by about 1/3.
Okay.
It reduces the wind sail effect, meaning the tree is less likely to blow over in a storm, and it reduces the overall weight. When done perfectly, you barely even notice the tree has been pruned.
So it buys the tree time. But even if we save the tree from the developer's bulldozer, we still run into the issue of public safety.
Always.
Standard city practice is to relentlessly hunt down and remove dead or sick branches because, again, they are a liability.
Liability is the driving force of urban forestry. A heavy, dead branch suspended over a sidewalk or a parked car is a very real threat.
I have to admit, I struggle with this part. If a dead branch is a literal safety hazard hanging over a pedestrian, city councils kind of have to remove it, right?
Yeah, of course.
We can't just let dead wood hang over our heads to be one with nature, can we?
Well, you are identifying the core tension here. No one is arguing that we should ignore human safety. But we need to be honest about the ecological cost of constantly sanitizing our environment to mitigate that liability.
What do you mean?
Well, out in a wild forest, a dead branch is not a hazard. It is a vital opportunity. Over time, fungi and insects break down that dead wood. It rots, it hollows out.
Oh, and those natural hollows become the real estate for the entire ecosystem.
Exactly. They become crucial winter roosts for bat colonies. They become nesting cavities for owl families. By constantly amputating any branch that looks a little tired or dead, we are systematically erasing the natural housing market for wildlife.
Wow. So a safe, perfectly manicured city tree is essentially a sterile biological desert. It looks green, but nobody actually lives there.
And the ultimate irony is that humans then have to spend money and resources to artificially intervene.
Right, the birdhouses.
Exactly. We stripped the environment of natural hollows, so now we have to nail little wooden birdhouses to the trees for small birds like tits to nest in. We destroyed the natural infrastructure and replaced it with plastic and plywood.
Which perfectly leads us into the new methods of pruning that Kesser and Steen are advocating for.
Yeah, this is where it gets really interesting.
If we legally and ethically cannot leave a massive dead branch hanging over a street, maybe we can safely create those missing microhabitats on purpose.
We can. And to understand how radical this is, we have to look closely at the physical scar left by a saw cut.
Okay.
For decades, the absolute gold standard in arboriculture was heavily influenced by researchers like the famous Dr. Alex Shigo. The prevailing wisdom was to make a clean, flat cut right up against the trunk.
The idea being that it looked like a clean surgical incision. It feels very human. You know, we like smooth, flat, clean things.
We do. We project our own biology onto the tree.
Yeah.
We think of it like putting a Band-Aid on a scraped knee. But trees do not heal like humans do.
They don't.
No. Humans regenerate damaged tissue. Trees compartmentalize damage, they wall it off. And Dr. Shigo's later research, which a lot of old-school pruners just ignored, actually showed that flush, flat cuts are terrible for the tree.
Wait, really? Why is a flat cut so bad?
Because at the base of every branch, there is a slightly swollen area called the branch collar. It is packed with specialized cells and chemical barriers designed to stop decay from spreading into the main trunk.
I see.
When you make a perfectly flat flush cut, you slice right through that collar. You destroy the tree's natural defense mechanism, opening the door for lethal fungi to enter the heart of the tree.
So the old neat and tidy textbook method was actually causing massive internal rot.
It was. Now, the modern habitat-focused method leans into this biology but takes it a step further. Instead of cutting flat or even just leaving a standard short stub, you intentionally leave a specific type of cut that encourages the tree to form a massive, bulging scar.
Right, the tree pushes out callus tissue.
Exactly, which is essentially protective scar tissue all around the wound.
The diagrams in the notes for this are wild. The callus tissue forms this thick, protruding ring around the exposed wood. Kesser and Steen call it a bait ring, which translates to a swim ring.
Yeah, bait ring.
It literally looks like a tiny organic life preserver made out of bark.
And that bizarre bulging shape is not an accident. That little swim ring creates depression in the center. It acts as a miniature organic reservoir. It is perfectly positioned to catch morning fog, dew, and light rainwater.
Here's where my mind was completely blown. We are intentionally hacking the tree's immune response to sculpt a tiny bird bath out of bark.
A bug bath, really. The sources note that this little callus pool might only hold about 5 milliliters of water.
Which is nothing.
Right, to a human, 5 milliliters is a rounding error. It is barely a teardrop.
But to a thirsty insect, it is an absolute oasis.
Consider the physics of a wild bee or a ladybug. They can't just fly down to a lake or a rushing river to take a drink. The surface tension of the water would trap them and the current would sweep them away.
Oh, that makes so much sense.
They rely on microdroplets. A 5 milliliter pool held in the rough bark of a tree branch is a safe, accessible, life-saving water source for an entire micropopulation waking up in the morning mist.
Just 5 milliliters sustains that much life. It really changes how you look at a tree's imperfections.
It really does.
We were deliberately creating what an old-school arborist would call a flaw, because that flaw provides an ecosystem service. We are valuing the messy reality of nature over textbook aesthetics.
It is a profound philosophical shift.
But if sculpting a delicate 5 milliliter bug bath is the gentle approach to habitat creation, the sources outline a final evolution of this practice that is, well, incredibly aggressive.
Yes.
It involves heavy machinery.
It does. The practice is known as veteranization, or in the original notes, veterinizing.
Veteranization. It sounds like a polite bureaucratic term, but in reality, modern arborists are taking chainsaws to living trees to violently simulate centuries of natural decay.
It sounds incredibly destructive, but it is highly calculated. You have to consider the timeline of a forest. For a tree to naturally develop the deep, complex crevices, the hollowed-out trunks, and the peeling bark that wildlife really depend on, it takes decades, sometimes centuries.
And city trees don't get that kind of time.
Exactly. Most city trees are cut down long before they ever reach that veteran stage. So veteranization basically fast-tracks the aging process.
So we are artificially aging the tree to force it to provide habitat decades ahead of schedule.
Yeah.
But I have to ask about the mechanics of this.
Sure.
Because there is an illustration from Kesser and Steen showing an arborist plunging a running chainsaw directly into the vertical trunk of a living tree.
Yep.
How does that not just instantly kill the tree?
It goes back to the anatomy of the trunk. A mature tree trunk is mostly dead wood. The very center is the heartwood. It is biologically dead. It is just there for structural support.
Oh, really?
Yeah. The only truly living, active part of the trunk is the sapwood and the cambium layer, which form a relatively thin ring just underneath the bark. That is the actual transport system for water and nutrients.
Oh, I see. So as long as you don't sever that outer ring completely, like as long as you don't girdle the tree, the transport system keeps working.
Precisely. A skilled arborist can plunge a chainsaw straight through the outer bark and carve a hollow into the dead heartwood without disrupting the flow of nutrients around the rest of the trunk. They are creating a custom-made cave.
And the notes mention these crevices are dimensioned specifically for bats to roost in, which solves a very real human problem.
It does.
Because as Kesser and Steen point out, it is much better that a bat colony lives in a custom chainsaw hollow down in the park tree, rather than finding their way up into your attic.
It is a brilliant compromise. You give them superior housing in their natural environment, keeping them out of human infrastructure, and the techniques get incredibly specific. They aren't just hacking random holes.
Right.
The arborists carve what the sources call rain hoods or casket skyger.
Little cap visors.
Yes, exactly. They carve a small, overhanging lip of wood just above the crevice. It functions exactly like the visor on a baseball cap. It deflects rainwater away from the opening, giving the insects or bats a perfectly dry place to shelter during a storm.
It is literal microarchitecture. Though Kesser and Steen do issue a warning here.
They do, yeah.
There is an extreme end to veteranization that maybe loses the plot. They talk about people getting a little too creative with the chainsaws and carving massive pockets into the wood that end up looking like the mouths of Bert and Ernie from Sesame Street.
It is an important caution. When you start carving cartoon faces or decorative patterns into a trunk, you are crossing a line. You are moving away from authentic habitat creation and drifting into destructive tree sculpture.
Right.
At that point, it becomes about human entertainment and aesthetic novelty again, rather than genuine ecological function.
Yeah, we don't want to just torture the tree for an Instagram photo. And that brings up the golden mean of all this. The goal of habitat pruning or veteranization isn't to go out into a productive young orchard and destroy perfectly good food-producing trees.
Absolutely not. I mean, humans still need food. Trees still need to be healthy enough to sustain themselves. This is about nuance.
Yeah.
It is about recognizing that not every tree has to serve the exact same master, and we also have to distinguish who we are doing this for. The sources are very clear. Honeybees are essentially agricultural livestock. We manage them.
Oh, that's true.
So when we do this kind of intense habitat pruning, we are primarily doing it for the wild insects, the native pollinators and beetles, who are rapidly losing their natural homes to urbanization.
So if you have a tree in your backyard that is getting old and it has stopped producing good, crisp apples, the standard human instinct is to chop it down, turn it into firewood to heat the house, and plant a new one.
Right.
But with this new paradigm, are we basically running a retirement home for tired trees?
That is a wonderful way to frame it. Veteranization proves that a tree's value does not expire the moment it stops producing fruit for human consumption. In fact, its second life as a decaying habitat can be far more crucial to the survival of the local ecosystem than its first life as an apple factory.
That's incredible.
You aren't losing a tree when it gets old, you are donating it to nature.
Donating it to nature, I love that. It transitions from being a food producer to being a housing developer for the neighborhood ecosystem.
And Kesser and Steen don't just leave us with the theory, they give us actionable advice for this. They suggest getting a sketchbook and a camera and simply going out into a wild forest or an unmanaged patch of nature.
Right, they say to train your eyes. Look closely for the natural hiding spots. The weird crevices, the rot holes, the peeling bark, the way a broken branch heals over.
Build your own idea catalog, take pictures, sketch the angles. It is an exercise in observation before intervention. Before you ever pick up a pruning saw or a chainsaw, you need to deeply understand the architecture that nature is already trying to build. You have to learn the visual language of decay.
This entire deep dive has been such a massive shift in perspective. It really leaves you with a completely new lens to view your surroundings.
It really does.
The next time you walk through a manicured city park, or even look at the landscaping in your own neighborhood, and you see a perfectly pruned, symmetrical, smooth-barked tree, realize that we have been completely conditioned to think that looks healthy. We look at it and think, oh, order is restored.
But underneath that visual order is a biological void.
Exactly. What if a truly healthy environment, one that actually sustains life, requires trees that look broken? Trees that are starred, bulging with callus rings, full of dead wood and riddled with chainsaw hollows? We have been prioritizing our own visual comfort over the survival of the ecosystem. And it actually makes you wonder about more than just trees. We look at a scarred, aging, unproductive tree, and our first instinct is that it is broken and needs to be removed. But as we just learned, that older tree is actually providing more value to its community than ever before. It is sustaining the next generation of life.
That's a profound thought.
It makes you wonder how much we project that neat factory line obsession onto ourselves. How often do we view aging and a lack of traditional productivity in our own human society as a flaw to be hidden away, rather than a vital, complex stage of life that enriches the whole community? Something to think about the next time you look up into the branches of a tired old tree. Thanks for joining us on this deep dive.